Okay, so we just finished the lecture and I've realised that rotten Zoom wasn't recording locally on my machine. So we haven't got a recording of our lecture, which is a real shame. So I'll go through everything just quickly again and upload this recording. So you remember at the start of the lecture I had to do a reboot because audio was a bit scratchy coming through. So you know, I've got it set up so Zoom automatically starts recording and it didn't. So damn. Anyway, we'll run through things quickly again and hopefully we'll get it right this time. Now, at the start of the class, we had a question on when do we get our assignment 1 marks back? And my answer was that you get them back 2 weeks after the due date or 2 weeks after the date you submitted, whichever is the latest. Okay, so if you submit on or before the due date, you get them back 2 weeks after the due date. If you've got an extension or you submitted late, then you'll get them back 2 weeks after the date you submitted, whatever is the latest. Quick roadmap of where we are, and we're here this week. We're in week 8, talking about advanced array concepts or semi-advanced. Okay, and so last week was all on basic arrays, and we talked about the for each loop and parallel arrays and arrays of objects, and how to pass methods, data to methods by value, which is what primitive types do, and then pass by reference for everything else. So dates, strings, employees, customers, products, everything else, arrays gets passed by reference, which means the method can change your data. And we talked about some of the dangers and the issues there, but really the solution of that's for a future topic. Okay. Now the golden rule when you use arrays is to always keep in mind that an array of size n has n storage locations indexed from 0 to n-1. Okay, that's the golden rule. So if you've got an array of size 20, you've got 20 storage locations from 0 to 19. If you've got an array of size 1,000, you've got 1,000 storage locations from 0 to 999. Okay, so keep that in mind. On to this week, we're talking about some advanced concepts. It's a week 8 PowerPoints. We'll talk about UML class diagrams, sorting, 2D, 3D, 4D arrays, rectangular versus jagged arrays, arrays of class, the Arraylist class, and enums. Okay, and we talked about all of these in the class, but Zoom wasn't recording, so I'm going through it again just quickly. Okay, so a little bit on UML diagrams, UML class diagrams. They're required for assignment 2. They're a quick summary of what your class is or what your class can do. It shows what methods and data are available, shows what's private and what's public and so on. You can do them as text if you want to, or you can draw beautiful diagrams using fancy tools. I don't mind them being text. And it's not even a bad idea to put them in the top of your class files, in top of your Java source files, so that you've got that UML diagram there if ever you need it. It's part of the code. It's part of the comments in your code, so it's very easy to keep them up to date. I'm not really that fussed on the accuracy of symbols and style. I'd much rather your diagram is clear and correct than having maybe issues and ticks and crosses in right places and things, special symbols. But for your assignment 2, you must follow the standards presented in the textbook, and you must follow what it says in the assignment 2 spec. Okay, so for assignment 2, you must read the spec and read the textbook. And the next thing we did was to create a UML diagram for our employee class. So let's just run through that quickly again. I've done it. We've done it already, so I'll just run through what we did. And we created this thing with just dashes there. Okay. And this is where your class name goes. So it's the employee class, whatever that class name there is, goes at the top. And this is where your fields go, your class fields and your instance fields. So your static data and your instance data. Okay. And we had a question of what happens if you've got arrays or static data. Okay. So we're going to a simple employee class here, and it's got an employee ID and a name, and they're both private data. The employee ID is an int, and the name's a string. So that's why we've got ID is an int, and name is a string. and they're private. So I've got a minus sign in front. Minus means private. Okay. And then just for an example, I put in a max ID. It's not used. I just wanted to show how you could represent constants if you wanted to. So we've got a private static final int max ID equals 999 there. So I can give that, there's probably symbols in the UML standard for static and constants, but as long as you make it clear in your diagram, it doesn't really matter what you say. Okay, so max ID is an integer. It's got a value of 999 and it's static. And we know it's a constant because it's got uppercase. Okay, and it's private, so I've got a minus sign there. If you want to have it public, you can have it public and put a plus sign there. Okay, so that's one way you could document it on your UML class diagram if you wanted to. That's probably not the right way, but that's the way that would be good enough for me. But again, like I said, for Summit 2, you need to read the your spec and read the textbook and follow exactly what it says in the spec and the textbook. If you had an array and it was a private array of training history or strings, you could show that as a minus training history, and then whatever the data type is, and then square brackets indicate it's an array, and so on. Okay, that's not part of this class, so it's just there for an example. Then we'll go on to our mutators and our accessors. So we've got a get ID that returns an integer, a get name that returns a string, and a toString which returns a string. They're all our accessor methods. They're accessing class data and returning it. Okay, so get ID returns an int, get name returns a string, and get ID or toString returns a string as well. And they're public, so they've got a plus sign there. Okay, so that's our accessor methods. Then we've got our mutators. So set ID is a void method, set name is a void method, and this one takes a string, which is a name. This one takes an integer, which is an ID. So an integer, which is an ID, and it's void, and a string called name, which is void as well. And they're both public methods. So they've got a plus there. And the way you show your constructors, we've got a default constructor, which takes no parameters. So that's our default constructor. So you just put constructor inside double less than, double greater than, or if you wanted to, single less than, single greater than. Okay. The UML standard is for doubles. It's pretty clear with just singles as well. And then we've got a constructor that takes a string of name. So a constructor that takes a string name. Another constructor that takes a string of ID. Another one takes a string of ID. And another one takes a string and an int ID. So both parameters or both types of data, string and an int. And there that one is there. Okay. And they're all constructors. Oops. So you put constructor in front somehow signify it's a constructor. You don't really need to put plus in front because it's taken as read that constructors are going to be public. You don't really need to put the void at the end because they're not really void. There's actually no type here. There's no public void employee. It's just public followed by employee for constructors. So void wouldn't be correct either. So just leave them like that. That's fine. Okay. And that's your UML class diagram. If you want to make things really clear, I always put a key underneath. So there's a little key to what I've done, and minus equals private, plus equals public. And you can say, this is indicating constructors, and static means static methods or fields. So you can put the symbols you've used in a little key and then say what they mean. Constructor. Okay. So even if you're not using the right symbols, because UML's pretty fussy, you can make it still really clear and understandable by putting a key underneath. And then nobody can misunderstand what's going on when you've got a key there. As long as your key is correct and right and accurate. Okay, so that's all you need to do for a UML class diagram. Okay, you can do it for your data classes. So employee, if you had a GUI class as well, you could also do it for the GUI class and any other class that you're using as well. Not a bad thing to do when you're creating a class. Put a little UML class diagram at the top here. Just a short summary of your class, and that was some questions I had. So that's it. I'll leave it to you to investigate constructors, the correct terminology. I'm pretty sure that's right, but just double check. And I'll leave it to you to check that whether that static's right or not. And if you're a assignment, you'll need to use the right notation. But like I said, just for general purpose, that would be good enough if it wasn't an assignment. So that's the UML class diagram. UML class diagram. So we'll look at sorting array elements using a bubble sort algorithm. We'll look at insertion sort. We'll talk about two-dimensional and other multi-dimensional arrays. We'll look at the arrays class, the arrays list class, and we'll look at creating enumerations just quickly at the end. So sorting is a process of arranging data in some sort of logical order. You've got usually ascending order or descending order, and you can sort by string value or integers, or if you're sorting employees, you could sort by employee number or start date or name or whatever you want to sort by. Ascending or descending order, it's really quite easy in Java. Okay, so ascending order is when you got from lowest to highest, and descending order is when you got from highest to lowest. Now, before you can do any sorting, you need to understand swapping, and swapping is actually the simplest form of sorting. When you've got two values and you want to swap them. So for example, here, so swapping is a key part of sorting. And if we've got two integers and we want to swap them, we introduce a third integer. So int temp, set it equal to the first one. So temp I equals I1, I1 equals I2. So I1 now is the value of I2. And then we want to restore the value of the original value of I1 into I2. So I2 equals temp. So after this little bit of code here is run, I1 will have the value of 44 and I2 will have the value of 33. The values will be swapped. Okay. We can do exactly the same thing with strings. String name equals Mike, name 1 equals Michael, name 2 equals Frankie, temp equals name 1, name 1 equals name 2, and name 2 equals temp. So exactly the same operations. Just instead of dealing with ints, we're dealing with strings. Okay, same operations. And after that code there is run, name 1 would be Frankie and name 2 would be Mike. Check it out for yourself. Write your own little program. Follow it through. Okay, you'll soon see. Okay. We can do the same thing with employees. Employee E1 equals new employee. Employee E2 equals new employee. Employee temp equals E1. E1 equals E2. And then E2 equals temp. And we'll swap the employees. So whatever this employee here was, it's now E2. And whatever this employee here was originally, it's now E1. Okay, so we're swapping the employees. So that's a key part of understanding sorting is swapping. And swapping is the easiest type of sorting. You're just swapping two values, sorting two values into ascending or descending order, whatever you want to do. Okay, here we're just swapping them, not even worrying about the order, whether it's ascending or descending. Okay, so that's that code there. So you can, so when you bubble sort, for example, an array, you're swapping adjacent pairs of items until there's nothing left to swap. You're comparing and swapping. Okay, you swap them if they're out of order, and you keep swapping and comparing until you don't do any swaps anymore. So if you're doing an ascending order sort, the smallest item becomes the top of the array or the first item in the array, and the largest item becomes the last item in the array. If you're doing a descending order sort, then your largest is at the start of the array and your smallest is at the end of the array. Okay, so the bubble sort, it's very easy to understand. It's a very simple sort. It's very easy to understand. It's very, very easy to code, but it's horribly inefficient. Okay, so if you double the amount of data, you quadruple the amount of time. Okay. Quadruple the amount of time. So this is a little example I gave in a lecture. 1223, actually, that was the original. That was the original data there. 12 23, 12, 55, 5. Let's sort that into ascending order. So we compare adjacent elements, 23 and 12. They're not in the right order, so we swap them. Okay. So we compared those first two. Then we compare 23 and 55, and they're in the right order. So we leave those alone. Don't do any swapping. And then we compare the 55 and the 5, and they're not in the right order. So we swap them. Now we've got to the end of our array, and we swap some data. So let's go back through again and check again. Okay. So now we compare 12 and 23. They're in the right order. We compare 23 and 5. They're not in the right order, so we swap them. Okay. And we compare 23 and 55, and they're in the right order. Okay. Now we swap some data, so we go through the array again. We keep going through the array over and over again, comparing adjacent elements until we don't swap any data. So we compare 12 and 5, and they're out of order, so we swap them. Then we compare 12 and 23. They're in the right order, so we don't swap them. And we compare 23 and 55, and they're in the right order, so we don't swap them. So we still swap the value. We swapped 5 and 12. So we're going to go through the array one last time just to make sure everything's okay. Compare those two, they're correct. Those two, they're correct. Those two, they're correct. Everything's sorted. Okay. So to bubble sort an array of integers, we can do that exact same process. Here's the code. Okay, so we've got an array of integers just with those same values in. Let's do it 23 and 12, 23, 12, make it exactly the same. Okay, 23, 12, 55 and 5. I've got a Boolean here to indicate whether anything was swapped during that traversing of the array. Traversing of the array just means going through the array and checking each element. Okay, so was anything swapped during that traversal? Set swap to true. While swapped is true, keep looping. Set the first line in here, set swap to false. And then in here, you try and prove it wrong. Okay, so for each item in the array, int k equals 0, k is less than array length, k plus plus. Now comparing the current element to the next element. Okay, and then the next time through the loop, I'm comparing the next element to the next element after that. Okay, so I want to loop through while k is less than array length minus 1, because I don't want to compare the last element in the array with something that's outside the array. I've blown the array size, my program will crash. I want to stop when I'm comparing the second last item to the last item in the array. Okay, so that's what I want to loop through k is less than array length minus 1. So very important. Okay. So once you make sure you're not going to blow your array size or try and access something outside the array, then you can say if array k is greater than array k plus 1, so is the current element greater than the next one, then we need to swap them. Okay, so we need to swap them around. And then we do our swap. There it is. It's the exact same code as up here, exact same code as that, except I've used array notation instead. So int temp is equal to one of the items in the array. That location in the array is equal to the next location in the array, and the next location is equal to the original value. So I'm swapping the values around. And then I say swapped equals true. Okay, so during this iteration of the loop, something was swapped, maybe multiple things were swapped. And the loop will keep looping while swapped is true. Set swap to false and go through the array again, over and over and over, comparing each adjacent element. If anything gets swapped, set swap to true, and then keep looping. We'll keep looping through the array over and over and over again until finally we get to the stage where things aren't swapped. Nothing was swapped at all, in which case this loop here will exit and execution will continue on down here after the loop, after the while loop. So I highly recommend students write the above code for yourself, explore it, put system out print line statements in there if you want to, and just verify for yourself that you're happy with that code. Okay, because being able to write bubble sort from scratch is pretty core knowledge for a programmer. Okay, let's do the same thing with an array of strings. Here's an array of strings. So I'll just change the data type to string, and we've got our array of strings there. We're going to sort that into ascending order. Same loop. Boolean swapped as true, while swapped as true, set swap to false. There's our while loop. Inside there's our for loop. Again, we're looping through until the length -1. Keep looping while k is less than length -1. And we're comparing the current element to the next element using the compare to method. And then if that returns a value greater than 0, then this string is greater than that string. Okay, so they're out of order. So we need to swap them. String temp is equal to array k equals array k plus 1, array k plus 1 equals temp. So we're storing array k plus 1 string in array k, and array k plus 1 gets the value that was originally in the first element. So we're swapping the values. Set swap to true. And then let's pretend we've got an array of employees. Okay, so same code. Here's an array of employees called Arrow, and we've got new employee Teeny and new employee Mike. So we've got creating a new employee and separating the values by commas. New employee Frankie, new employee Bella, new employee Sam. So we've got 5 employees there, and each employee is separated by commas. That's an array of employees. And here we did the sorting a whole bunch of ways in class. Let's start with the first one. And we're doing it in name ascending order. Okay. So the while loop's the same, the swap to false is the same, this is the same. Now we're going to work out how to compare employees. So if the current employee's name is greater than the next employee's name, and we're using the compare to compare strings. So if the compare to is greater than 0, then we've got something that's out of order, and we need to swap the employees. Just the same as you saw above. We're just using that exact same code you saw up here to swap employees. Exact same code, except now we're getting the data out of an array and putting the data into an array. So employee temp equals the employee at that location. The employee at that location is the next employee, and the next employee is the original employee in the first location. Set swap to true. Okay. And that was for an ascending order sort. And I asked the questions, how do you do a descending order sort? And the answer is very simple. All you do is flick that sign there. So you make that greater than or less than, and you got a descending order sort. So now you're sorting in descending order of name. And what if you do an ascending order sort of employee ID or something? Then you can just call the accessor methods for that. Get ID, get ID. When you're doing name, it's get name and get name. When you're doing ID, it's get ID and get ID. If you had start date and you want to sort by start date, you would get date and get date. Okay, whatever it might be. And again, to do, or else you can do so you can do ascending order greater than, or you can do a less than for descending order, or else you can just compare them directly because they're just integers. Get an employee ID is an integer, so you can just compare them directly. So you can get the ID of the first one. And if it's greater than the second one, then that's a shortcut to doing compare to. It's just a little bit less code. And again, if you switch that to a less than sign, that would be a descending order sort. Okay, so ascending, descending, super simple. Sorting by integers, strings, employees. It's all virtually the same code. All you're changing is the data type here and whether you're calling accessor methods for it or whether you're calling compare to compare strings or whatever. Okay, so how you do the comparison might be different, but the code is very, very similar depending on whether you're sorting integers, strings, doubles, dates, employees, customers, products, whatever, doesn't matter. Okay, so you can have arrays of anything and sort it very easily, ascending or descending order. So we've got lots of very similar code above. It's very, very similar. The only thing we're changing is how we do it, what we're calling here, really, and what data type this is. That's really all we're changing. Okay, and even up here for integers, you can actually call compare to compare integers. So we can make that a lot like the string code, where we're comparing adjacent integers with compare to. Okay, so we've got lots of very, very similar code here. What can we do about it? And at this stage, nothing. Okay, in the follow-on course, we do have a month on or a week on generic methods, and we'll look at making the above code work for all Java data types, or all the data types we need it to work for. Okay, It's not particularly difficult, it's just in the follow-on course. We don't want to do too much too early. Okay, so see the follow-on course. Object-oriented programming, or whatever that course there is. It's COIT11222 is the course code. Okay, so back to our PowerPoints. So you continue to compare JSON items and swapping them if they're out of order until you go through the array and you don't swap anything. Then you can stop. There's some code to do it. We looked at, this has got a double for loop. So you need a nested loop. You need a loop within another loop. This one's got a for loop within a for loop. That's quite okay as well. And we're just comparing JSON items and swapping them if they're out of order. That's quite okay. But this one doesn't have the option to bail out early, because we've got this loop here, goes through, if the array's length 20, it'll go through the inner loop 19 times and the outer loop 19 times, no matter what, even if there's no swaps occurring. Okay, so my code here was more efficient because it allowed the opportunity to bail out early if no swaps occurred. Okay, and then there's another slight improvement here. You can keep track of the comparisons to make, and set that equal to the array length -1, and then each time through the outer loop, you reduce that by 1. So you can gradually bring the data forward through the array as you're running out of values to move back to swap. Okay, because if you swap the last 2 elements in the array, that element, the smallest elements now out of those 2 is now at the second last location in the array, and if you swap those, the second last and the third last elements, that's now at location 3 back. So you can use this little, little optimization here where you're looping through slightly less times each time through the outer loop. So making that inner loop less times, 1 less each time through that this each loop to the outer loop. So that's a slight improvement as well. But this way here is still better, because if you go through the loop, if you go through the array once and there's nothing swapped, you can bail out straight away. This way here will keep looping for quite a while yet. So in terms of efficiency, that's probably about as good as you can get for bubble sort. It's very easy to code, it's very easy to understand, but it's horribly inefficient, like I said. So you've got a whole bunch of search methods or sort methods. There's bubble sort, there's insertion sort, there's other ones as well, which are really easy to code, really easy to understand, and they're horribly inefficient. If you double the amount of data, you quadruple the time. And there's other ones like merge sort, shell sort, hash sort, and tree sort, many other ones like that. And they're relatively hard to understand and relatively hard to code, but they're a lot more efficient. Okay, if you double the amount of data, you might only slightly increase the amount of time required. Okay, not double it or quadruple it. Okay, but that's something we'll talk about in a follow-on course again. Even then, we don't go very deep. Okay, we really need a third and a fourth Java course to cover these things in detail. If you want to have a look at some algorithms to help you visualize sorts, there's a web page there that Wayne recommended. Look at it in class. And also written a little visualizer here that's using some third-party code. I'll just run that for you quickly. And I'll click the start button, and you'll see slowly that all the big elements are going to the end. And it's slowly looping through less times each time as well. Okay, you can see now our data's sorted into ascending order. So sort visualizations there. If you're not sure what's going on, they can really help you as well. Okay. If people want me to make that code available, I'm happy to do it. It's using a third-party library. It's really easy to set up and run. I've got it working here. So we haven't done GUI programming yet, so I'll probably leave it till after the GUI if people want to look at that code. Back to the slides. You can sort arrays of objects in much the same way than you can sort primitive types. The major difference is the comparison that determines whether to swap the array elements. So are you calling a compare to method? Are you calling a dot get name or a get ID or get hire date or some other method to compare? So you can sort really easily based on particular fields inside classes as well, using the accessor methods. Okay, so you get the data at that location for that employee, get the data at the next employee's location, and then compare them with compare to or whatever. Insertion sort's a very similar algorithm to bubble sort. It's slightly different, but it's very similar sort of code length and code complexity. So you look at each element in the list one at a time, and you move items down if tested elements should be inserted prior to the other elements. So basically you're going through the array, finding the smallest, moving that to the front, then go from the second element onwards, find the next smallest element, move that to that location. Then you start the third element, find the next smallest, move that to there, and so on. Similar efficiency, similar complexity, similar amount of code to the bubble sort. There it is there if you want to follow it through, but in class we didn't really worry about it. Understanding bubble sort is really enough for what we're doing at this level. Then we moved on to one-dimensional arrays, and an array that you can picture as a grid, as a row of pigeonholes or a column of pigeonholes. That's a one-dimensional array. Each element's accessed using a single subscript inside square brackets. Okay. When you've got two-dimensional arrays, you've got two lots of square brackets. For example, here, int square bracket, some numbers equals new int 3 and 4. So two lots of square brackets, two lots of square brackets. You can specify the sizes in here, although normally you'd specify constants. And normally the first one's number of rows, number of columns. Just think of them that way is probably an easy way to go. Okay. So to access each element in the array, you've got to use two subscripts, two integer values, or two integer constants, or two integer variables. So they're a matrix or a table of, or a grid of rows and columns. So a grid of pigeonholes. And we look at this example here. We've got a 2D array, int square bracket values array equals new int 510. So it's a 5 rows and 10 columns array. So 5 rows down and 10 columns across. And then you access each element in the array using two numbers. So 0 zeros, rows, the first row, the first column is 44. The first row, second column is 12. First row, third column is whatever. And each of these, so you've got 5 rows and the indexes are 0 to 4. You've got 10 columns and the indexes are 0 to 9. Don't forget that. It's very important that you remember to, you've got that many locations, 0 to n-1. Don't forget that rule still applies for all arrays. 1D, 2D, 3D, 4D, whatever. Okay, so 0 to 9, you can put a value there, and then you can move on to row 2, which is index 1, up to 9. Then you can move on to row 5, which is index 4. And that's it. You can't go past 9, and you can't go past row 4. Otherwise, you'll have an index set of bounds error for your array, and your program will crash. Okay, you've exceeded your array size. You've gone outside your array bounds. Do the same thing with strings. String square bracket names equals new string 1019. So you've got 10 rows and 99 columns of strings. Each string can be any length you like, hundreds of kilobytes, hundreds of megabytes, whatever you like, until you run out of memory. It's a big storm outside. Wow. Okay. Here we're going to array of employees, and employee square bracket employees equals new employee, and we might have 10 cities, so 10, and each city could have up to 1,000 employees. Okay, and if Melbourne's city 0, then we could say employee 0, employee at city 0, employee 0 is new employee whatever, employee at city 0 at Melbourne, employee 1 is new employee city Melbourne, employee 999, so we've got 0 to 999 locations equals new employee. Then we're going to move on to city 1, which might be index 1, 111, okay, and so on. Or if you want to do it a better way, rather than putting the integer values there, it's much better to use variable names to make it clear. So city equals 0, that means Melbourne. Employee equals 0. And then you go city for all the employees at Melbourne, and M++. Okay, so we're using the current value of emp, which is 0. So city 0, 0, and then we're adding the 1 to the value of emp behind the scenes. So down here it'll be 1 and so on. So we're adding 1 to it after we've used it. So look back onto our slides where we cover those univariate operators, plus emp and plus k and k++ to refresh your memory there. Okay, then you can move on to city 1, which is Rockhampton, and set employees back to 0. And city, employee plus. That's all the Rockhampton employees and so on. That's an easy way to do it. And of course, normally you'd be reading these in loops anyway. So you'd be looping through all cities and all the employees and maybe reading them in from a file or loading them in from a database or something like that. If you want to hard code your own 2D array, so if you know the values at compile time, you can load in your own 2D array. So here I've got an array of names and addresses, a 2D array of names and addresses. So string and string, square brackets, names and addresses. So Mike and 123 Smith Street. And I started off with just the names and addresses, and I added some extra data in just to show you that you could do that as well. Okay. And then, so that's my first name and address. That's row 0. Okay. So there's 1, 2, 3 columns in there. And then a comma. So curly bracket, that's the first row. And then the comma indicates the end of that row. Then we move on to the next row in the array. So that's our next row. And we've got Frankie at 45 Barkey Street. He shoots through any course he's human. He's my little doggy. And so on. So this array's got 2 rows and 3 columns. 2 rows, 3 columns. Okay, so if we use name and addresses.length, the length property, that will give us the value 2, which is the number of rows in our array. Okay, so we've got 2 rows, 1 row, 2 rows. So it'll give us the size of this first dimension, which is 2 for that array above. And then name and addresses 0.length will give us the number of columns in row 1 or in the first row. So it gives the number of columns here, which is 3. 1, 2, 3 columns, 3 bits of data separated by commas, 3 strings separated by commas. Or we can also go names 1.length, which will give us the length of row 2. So that's row 2, which is index 1. 1, 2, 3 strings separated by commas. So that's also got a value of 3. In fact, I'll say first row, just to make it less confusing between indexes and row numbers, second row. Okay, so 2D arrays, you can create them from scratch. You can use variables to help you work out what each of the dimensions means. So city means city for the first one, employee number for the second one, and so on. So you can write code like that to make it really easy for you to understand what's going on. I highly recommend you do that. You use variables, don't just go 0, 0, 1, 0, because you'll lose track very quickly, especially when you start dealing with 3, 4, 5 dimensions. Okay, so we've got, let's talk about dimensions now. So single dimensional arrays, 2-dimensional arrays, and let's talk about what happens after that. So when you've got sales, just a single dimensional array of sales, it might be doubles, an array of doubles, then you've got the sales per salesperson. For example, sales 0 might be sales for Mike. Sales 1 might be sales for Frankie, but that doesn't really tell you a lot. Okay, what does that mean? How long has Mike been with the company? Is it sales for the whole time he's been there? That's not very useful, is it? You want to know sales for the last month or sales for the last quarter. Okay, so let's extend that. So when you've got data like this, it's all summarized and not really useful, not really understandable. You can't really do much with it. So you want to go down into more granular levels, and that's where you can add extra dimensions into your array to get those granular levels. Okay, so let's add another dimension. So now we might be talking about sales by salesperson by product. Okay, so the first dimension is the salesperson. The second dimension might be the product. Okay, so sales 0, might be sales for Mike for PCs. Sales 1 might be sales for Mike for hard drives. Sales 2 might be sales for Mike for monitors. Okay, so 0, 1, and 2 are the product codes. and 0 is the salesperson index. Okay. So pretty useful, but still, is that for the whole time they've been at the company, or is it the last year, or what? It's not very useful. If it's just for the whole time they've been at the company, it's not very useful again. So let's break it down by year. Okay, so we need to add a third dimension in. 3 lots of square brackets. And now we've got the sales by salesperson, by product, by year. Okay, so salesperson, that's the first dimension. Product is the next dimension. And year is the third dimension. So now we've got sales for Mike for PCs for 2020, sales for Mike for PCs for 2021, getting ready for, so we can now keep multiple years of data. Okay, so now we can compare sales by salesperson, by year, by product. Okay, so what we can only compare sales by salesperson here, and it's maybe for the whole time they've been with the company. Here we can do it within certain timescales, by product, by salesperson, by year. So our data is a lot more granular. We've now got a cube of data. Here we had a row of pigeonholes. There we had a grid of pigeonholes. Now we've got a Rubik's cube of pigeonholes. Okay. And now we can compare sales by salesperson, by product, by year. So it's a lot more useful, our data now. Now we can start looking at who our best salespeople are. Where are the most sales happening? Which regions? Which products are selling the best? Which products are selling the worst? Okay. Now we can start thinking about those sorts of questions. We can improve it even further by adding a fourth dimension. For example, that might be day of the year or quarter or month or week or whatever you want to do. Okay, but I've done it by day of the year. So that's the salesperson, that's the product, that's the year, and now we're adding the day of the year. So 0 might be sales for Mike for PCs for 2020 for January 1st. 0001 might be sales for Mike for PCs for 2021 for January 2nd, and so on. Okay, so you can see our data is getting even more granular. Now we can compare sales by salesperson, by product, by year, by day of the year. So we could total up all the sales for January if we wanted to, or total up all the sales for the January to March quarter. And we could compare salespeople, we compare products, we compare regions. Sorry, we don't have region in yet. Sorry, I jumped ahead because I've done this in a lecture. It's still fresh in my memory. So, okay, we haven't got region in there yet. Sales by product, sales by product by year, sales by salesperson by product by year, by day of the year. Let's add a fifth dimension, and that could be region. Okay, so now we've got a region in there. So we keep track of the sales by Mike for products, by per year, per day of the year, by region. So Rockhampton, Melbourne, Sydney, Brisbane, and so on. Okay, so all of the regions where Mike might sell products. You might only just sell them in the Brisbane area or the Sydney area. Okay, but it's in his region. You could then do it. If it's only Sydney, you could keep it by suburb. So you might sell more to the northern suburbs than the western suburbs, or more to the western suburbs than the southern suburbs, or more to the Blue Mountains region than the city centre, or something like that. So once you've got this data at the lower levels of granularity, so it's more finely granuled, then you can answer more questions and see what's really going on. Do graphs, see what's going on. Okay. And we could add more dimensions as well. For example, you might add a scenario dimension. And scenario could be the actual sales, and you might have forecasts for a great year, forecasts for a bad year, and so on. So you might have different scenarios for each year, for each salesperson, for each product, for each region, for each day of the year. Okay, you might have different scenarios. And so once you get down to that level of granularity, then you can start answering really detailed questions. Was this year a good year? We forecast this as a good year. Did we actually achieve our targets for a good year? And if not, why? Okay. And, somebody, Frankie's sales for Brisbane's waterside suburbs might be really good, but Mike's sales for those waterside suburbs might be really low. Why? Well, Mike might be selling more PCs in those suburbs. Frankie might be selling more monitors in those suburbs. Why? You can start answering these why questions and see what's going on, and graphing data and looking at trends and seeing what's going on. You can see which products are selling good, where and by who, and you can see which products are selling badly, where and by who. And you might actually end up phasing out products. If they're not selling well, that might not be worth carrying. Okay. Whereas if you find new products that are selling really well, Get those into your supply chain as quick as you can. Okay, so when you get down to the lower levels of granularity, you can really start to understand what's going on with your business. Up here, one-dimensional array, you didn't have a clue. The data was meaningless. It's only when you break it down that you really understand the data. Okay, so a lot of textbooks, and this is a point in the lecture, a lot of textbooks say, oh, it's very rare you'll go beyond 2 or 3 dimensions. And in my experience, my industry experience of the best part of 4 decades, that's not true at all. You often go beyond 3 and 4 dimensions. You're often. Okay, so once you get beyond 3 dimensions, don't try and visualize the data. Okay, don't try and think of it as a hypercube or anything like that. Just remember the indexes and the order. So the first one's salesperson. So think of it like this. That one's salesperson. This one's product. That one's year. That one's day of year, and so on. Okay, so think of it like that. Just remember what the order is of the dimensions: salesperson, product, year, and just access the array that way. Okay, then you can't go wrong, really, no matter how many dimensions you got. Just keep things organized. Okay, so my point is that industry needs more detailed data to survive, businesses and so on. You know, margins are getting squeezed, competitors are moving in, you know. Competitors are always moving. Business really needs to know what's going on. Compare scenarios, compare regions, compare salespeople, compare years, products, so on. Did we meet our forecasts for a good year? If not, why? What went wrong? How big was the difference? How far were we out? Were our forecasts just wildly optimistic? Or were we, did we just have a bad year? No? Did coronavirus strike, which is basically slaughtered everybody? Okay, so everybody's business. Okay, and of course, if we're talking about databases here, if you've done databases, this is how that data might look for the for this sort of situation here. You'd have 1, 2, 3, 4, 5, 6 columns of data, which are IDs for an employee ID, a product ID, a region ID, a year ID, a day of the year, and a scenario ID. And then you'd have the sales figures for that employee, product, region, year, day of the year, and scenario. Okay, so that's how the database table would look. So you'd have six columns and then a data column, and it's the same thing with arrays. You've got 6 dimensions, and your data is that value referenced by those 6 dimensions. So there's visualizing 2D data. So you go 0, 0's row 0, column 0, row 0, 0, 1's row 0, column 1, and so on, until you get down to 2, 3, which is row 2, column 3. Okay, they're the index values, of course. It's actually the 3rd row and the 4th column, but you go n-1, don't forget. Arrays all start at 0. Every index starts at 0 in arrays in Java. There's another multi-dimensional array just to show you one hard-coded. So that's row 1. That's row 2. That's row 3. And that's row 4. So each row has got 3 columns. And this could be, for example, if you've got different types of apartment. This might be an inner city apartment, inner city luxury apartment, and that could be an outer suburbs standard apartment, maybe. Okay, so a little bit cheaper. And this could be values depending on the lease length. For example, that could be a 12-month lease, a 6-month lease, and a 3-month lease. So the longer lease you sign, the cheaper rent you get. Maybe that could be a thing. I'm just trying to make sense of this data. I don't know what it means. I'm just making it up. So that could be how you could think about it as well. So you could have different apartment types for the rows and different apartment rents depending on the length of the lease. That could be a way to make sense of the data. You can pass the array name. So when you're passing a 2D array or a 3D array to a method, you've got to supply square brackets for each dimension. So with single square brackets for 1D array, 2 square brackets for a 2D array, 3 lots of square brackets for a 3D array, and so on. And like I said earlier, the length field holds a number of rows for the array. And if you go square brackets 1, that holds a number of columns for that row. So that's the second row. Row index 1 is the second row in the array. Okay, let's talk about ragged versus jagged arrays. So a ragged array is a 2-dimensional array where the rows have different lengths. So you've got different numbers of columns in the rows. And this can apply to high dimensional arrays as well. You've got different slice lengths depending on the part of the array you're in. Okay, so a rectangular array is usually just everything's all nice and the same length. And a ragged array or a jagged array or a scruffy array is an array where things vary depending on the rows and columns and whatever. To create a ragged array, you define a number of rows for a 2-dimensional array. Do not define a number of rows and a number of columns, and then you can declare the individual rows as you go. So that's to create a ragged 2D array. Okay, you can also have ragged 3D arrays and 4D arrays and 5D arrays and 6D arrays and whatever you like. Okay, so here's a nice rectangular array, a rectangular 2D array. So our first row has got 1, 2, 3 columns, and our second row has got 1, 2, 3 columns. So it's 2 rows by 3 columns. The row lengths aren't changing. The number of columns in a row is not changing through the array. So that's a nice rectangular array. The slice size does not change. Okay, but a ragged array or a jagged array or a scruffy array, that's when you got, for a 2D array, that's when you got the rows changing number of columns. So here I've got Mike, 2, 3. So the first row's got 3 columns. Our second row's got 1, 2, 3, 4, 5 columns. Our third row's got 2 columns. Our fourth row's got 1 column. And our fifth row's got 1 column. And our sixth row has got nothing. It's a null entry, so it's got no data at all. Okay, so there we've got a really jagged array where we've got things all over the place. And of course, you can declare arrays in different ways. That's hard coding the data when you know what the data is at compile time. But if you don't know what the data is, you can do it other ways as well. For example, here I know that I need 5 rows, and I don't know how many columns I need for each row. So I can say names and addresses 0 for the first row equals that. So it's just that data there straight out of the array. Just that there with a semicolon on the end. Names and addresses 1 is equal to that, which is our second column out of the array with a semicolon slapped on the end. Okay. And so on. So that's another way you can do it. Or else you can declare that even more granularly. You can say you've got 5 rows, but you don't have any columns each row's got. And you can say string name address is 0 equals new string 3. So we're going to store 3 strings in that first row. And the first string is Mike, the second string is that, and the third string is human. So it's just that data there, put into the array. And then I can say name and address is 1. So that for the second row is new string 5. So I'm going to store 5 strings in the second row. And I can put Frankie and then Barky and Shih Tzu and all that rest of the stuff in there. Okay, so that's our jagged and ragged arrays. Just when you've got different slice lengths depending on where you are in the array. It's not nice and even for every row and column and whatever. Okay. So we've seen all that there. We've talked about multi-dimensional arrays. We just did it above. Create arrays of any size. Keep track of the order of variables needed as subscripts. Do not exhaust your computer's memory. So when you start adding dimensions like up here, so if we added a 7th and an 8th dimension, so when we add a 7th dimension, if we add 10 items here, then we've multiplied all of that data by 10. If we add another 20, something with 20 items here, then we've multiplied all of that data by 20. So our amount of data is increasing exponentially each dimension you add. So you can very quickly run out of memory, even on an 8 gigabyte or 16 gigabyte PC. You can quickly run out of memory if you keep adding dimensions. I should have another one, sorry. Okay, so you can quickly run out of memory because it's going up exponentially every time you add a dimension. Now with Java, with the 32-bit version of Java, you've got a certain memory size, 2 gigabytes or around about there, unless there's tricks involved. With 64-bit Java, you've got a huge amount of memory you can use. Basically, modern current PCs don't have enough to exhaust the 64-bit values. They won't for hopefully quite a while. So 64-bit really, you're only limited by the amount of memory in your machine, 8 gig, 16 gig. And you can hit that pretty quickly. And when you run out of memory, you'll see a heap size exception. So when you see data like that, you'll see errors like that come up. Your program will crash and it will see a heap size or something like that exception. And that's the clear indication you've used too much heap in a Java virtual machine. In other words, you've run out of memory in your machine. And so if you're running a 64-bit OS, install 64-bit Java, and that will get you around that. Gives you a huge upper limit. Okay. So that's memory and arrays. There was no questions there in class because I haven't copied and pasted anyone who asked a question. I copied and pasted it straight into the file here. So we had no questions at this stage. Everyone was pretty happy. Then we moved on to the array class. So the arrays class in Java is fantastic. It's got a lot of useful methods in there. They're all static methods, which means you use them with the class name. So it's arrays dot method name. You don't declare an object based on arrays and then call it for the object. It's arrays dot method name. They're all static methods. One of the methods is binarySearch. And there's two ways to search through data. So the import for arrays is Java util.arrays to bring that in for your program. So it's ready to use. Just a normal linear search. You should loop through the whole array until the data is found or until you get to the end of the array, in which case the data wasn't found. And it's a linear because if you double the amount of data, you double the amount of time. Okay. There's also a binary search, and that's for that your data must be sorted. So if your data is not sorted, it won't work. It'll give you incorrect results. So your data must be sorted. Ascending or descending order doesn't matter, but it must be sorted. And the binary search works on dividing the array in half and comparing what you're searching for that middle element. Okay, so compare them. If what you're searching for is less than that middle element, then you divide the first half of the array in half again and go to that middle of the middle element. Otherwise, if it's greater, you go to the top half of the array and go for the middle of element of that top half of the array. And you keep dividing the array in half, depending on how your value you're searching for compares to that middle element of that next part of the array. And it converges very quickly. And if you double the amount of data, then you barely increase the amount of time. So you can go from 1,000 items to 2,000 items, and the binary search just might go from fractions of a second to slightly more fractions of a second. Okay. Or if you go from 1 million items to 2 million, or if you go from 1 billion items to 2 billion, you'll barely notice the increase. Whereas with a linear search, if you go from 1 billion to 2 billion, you will double the amount of time. So it might be from 5 seconds to 10 seconds, depending on what you're searching for. Okay, but here we'll go from fractions of a second to slightly more fractions of a second. That's super fast. But like I say, data must be sorted. And what we're talking about here is something we'll talk about in the follow-on course, Big O and efficiency. And we'll talk about that with algorithms. And that's all subject to the follow-on course. Okay, so we talk about the basics in this course, and in the follow-on course, we talk about the more advanced stuff. And even then, we don't talk about it in much detail because we really need a third and a fourth Java course to get into the real nitty-gritty of what's going on. Okay, so there's some of the array methods there, arrays class methods, binarySearch, equals, fill, sort, parallel sort, and so on. They're the main ones you'll probably use. If we have a look at the Java help on that. Ooh, arrays, there it is. The arrays, there's the import, Java util arrays. You've got binarySearch and copy of, you can copy stuff. You can copy part of an array to another array. You can copy all of an array to another array. There's a whole lot of stuff you can do. You can equals arrays to compare them. You can fill arrays. You can do all sorts of stuff. Okay, so I'll let you look through that. That's all in the Java help. So the arrays class, some very useful stuff in there. So here we're declaring an array of size 5 called MyScores, and each integer in that array is initialized to 0 by Java automatically. But here we're filling the array with 8s, value 8. I don't know why, just filling it with 8. So arrays.fill MyScores, that's the name of the array. Fill every value, every element with the value 8. And then we can change some values. MyScores 2 equals 6, MyScores 4 equals 3. And then we can sort the array, arrays.sort MyScores. So we're calling the class.method name, class.method name to sort the array. If you want to sort it in descending order, you can just go comma with a parameter value there to say that you want to sort it by in descending order. And then we're doing a display to display the method. You can also get the data out on screen using the arrays class as well. There's a two-string method that gets the data out, so it saves you doing this sort of thing. But, displays just looping through, displaying all the element values separated by spaces. So just like we've done in the tutes already. So that's using some arrays class methods. Another one. So here we're going to use a binary search. So we've got an array of chars, B, E, K. So they're all sorted. They're all in sorted order. An array of chars. And we're prompting the user to enter a char or a product code, which is a string. Everything comes in from an input dialog as a string. Then we're getting the first character of that string. So if they type in 5 characters, we're only going to get the first character. So char at 0 gives us the very first character in the string entry. And we're storing that in users code. Then we're doing an arrays.binary search in our codes array, and we're trying to find what the user entered, what code they entered. So the first character, user code. And that's going to return a value which is either positive, and it's going to be the index location of that code inside that array. So 0, 1, 2, 3, 4, 5. So if that binary search returns 0, then the user entered the value B, uppercase B. If it returns the value 3, then the user entered 0, 1, 2, 3. So the user entered the value M, and we found that location in the array. Okay, so otherwise, if position's less than 0, the value wasn't found. Usually it's -1. If position's -1, it's not found. But just if position's greater than 0, it was found. Greater than or equal to 0, sorry. Greater than or equal to 0, it was found. And you can see what the position was. Otherwise, it wasn't found. So that's binary search. Pretty easy, and it's built into Java for basic arrays. Okay, so it's there ready to use if you need it. In the follow-on course, we'll actually develop our own binary search to do our own binary searches on employees and things, arrays of employees, but that's in the future. Then we've got the Arraylist class. So there's no questions on that. Everyone was happy with arrays. Everyone was happy. There's no questions there. There was no questions up here on declaring 2D and 3D arrays. The only question here was that someone said they rarely use 4D or higher dimensional arrays. It depends on what you're doing. Okay. If you're working in industry and they've got data that they want to build data warehouses off, or data they want to analyze and see what the trends are and what's going on, then it's quite often you'll end up with 6, 7, 8, 9, 10 or more dimensional arrays. Okay. Then we moved on to the Arraylist class. And the Arraylist class provides some advantages over arrays class. And the main advantage is they're dynamically resizable. So you just declare an array list and you can just keep adding data into it. You don't have to worry about the size of the array until eventually you run out of memory. If you add enough data into the array. So Java takes care of the resizing automatically behind the scenes. You don't have to worry about that. And you can add items at the start of the array, the end of the array, or any other place in the array. So you can add them in the middle of the array anywhere you like. You can remove items. You can get the size. You can clear the array. It's all really, really easy to work with. There is a capacity as well where you can declare the capacity of the array list. So if you know you're going to store 1 million items in an array list, you can give it that capacity at the start, and it just makes your code a bit faster to add data into it. It just saves Java from resizing it all the time and copying data over to a new location, which Java does behind the scenes. So if you know the size of the array up front, tell Java and it will make your code a bit faster. Okay. Let's have a look at Arraylist. So it's imports Java util.Arraylist, and you can declare an array of names or an array of strings called names. So Arraylist less than name greater than names equals new Arraylist less than string greater than round brackets. Don't forget your round brackets. Don't forget, over here, since Java 7, you can leave that out if you want to. Okay, but I still put it in because I'm just so used to doing it that way. Okay, but Java 7 did allow you the shortcut to leave that, to take that out if you wanted to. Okay, but you still got to put the less than greater than there, which looks funny being empty in my book. So, okay, now we've got an array called, or an array list called names, and we can use the add method. So names.add Wayne, names.add Sanjin, names.add Jared. So after those 3 commands are run, Wayne would be the first item at index 0, Sanjin would be the second item at index 1, and Jared would be the third item at index 2. And if we said names.add, and it's 1, Frankie, I think. Okay. So we're inserting Frankie at location 1 in the array. Then Frankie gets inserted there where Sanjin is. So Sanjin gets shuffled down. Okay. So after that command there is run, we would have Wayne, Frankie, Sanjin, Jared. If I said names.remove 2, then I'm removing the item at the name at index location 0, index location 2. So 0, 1, 2. So Sanjin's going to get removed. So our array list would look like that. If you need the size of the array list, you can just use the size method, so size round brackets. If you need to clear a method, there's a clear method that erases everything in the array list. And so on. There's a whole bunch of useful methods there. And if you want to get the data at a certain location, you can say get 1, and that would return Frankie. I inserted a new example up there before I did that. Okay, so I inserted this after I did that. So names.get1 would return Frankie. Names.get0 would return Wayne. Okay, so that's an array list of string. You can also do an array list of employees or whatever other data you like. So here's an array list of employee called emps equals new employee. And I could say emps.add new employee, emps.add new employee, emps.add new employee. Just keep adding employees as much as I like, passing whatever parameters are needed to the constructors, whatever is needed. I could be reading this data from the user input or reading the data from file or database or whatever I like. Okay. So adding a bunch of employees to an array list. So after those 2, 3, 4, 5, 6, size would return 6. Get 0 would be the first employee in the array. So array lists still start at 0. Okay. So if I want to get names of all the employees in the array list, I could say int k equals 0, k is less than emps.size, or k++. System.println emps.getK. So that's getting the employee at each location in the array, and I'm getting the name for that employee. So that's getting the employee, get 0, get 1, get 2, get 3, and so on, and I'm getting their name. Okay, so that loop there would list all the employee names to the screen. Okay. A question made or comment made in the class was it seems much easier than implementation. That was fixed in class as well. Implementation that I remember from C++. Yeah, fair enough. Yeah. C++ is pretty easy as well with array lists, but yeah, Java's pretty good. It looks after you. Another question asked was, is it better to use a database manager like SQL for bigger arrays? And the way I answered that was it depends. So if you just need to download, search and update a bunch of data and then maybe flush it back into the database, then it can definitely be a lot faster to keep your data locally in arrays. Up to like 1,000 times faster than a database, even more, tens of thousands of times faster. Okay. But if you've got multiple people accessing data, changing it all at once, okay, and it's too risky to take a copy of the data, process it locally, and then send it back to the database, if that's too risky, then you probably definitely want to use the database and keep everything on the database. Okay, but that's really a question for a future course. Okay, we're getting a little bit off track here with these two. Okay, so with Arraylist, you've got add, get, remove, clear, and size. They're the main methods you're going to use. There's other methods there as well. Let's have a look. Arraylist. So you've got, there's the add method and the add at a certain location. The clear method to remove everything. The contains to see if it contains something, so you can do a search without writing your own code. You can just go .contains, pretty easy. Index off to see if it contains a certain string or employee or whatever. Is empty to see if the list is empty, or else you can just go size equals 0. Remove size and so on. Set as well. Set's another command that's really useful. Set. You can overwrite something at a certain location. You could say names.set 0 to Frankie, and then that name would change to Frankie. So the set command to overwrite something that's already there. Whole lot of good stuff in there anyway. Have a look at the help. Okay. And if you need to know what the import is, there it is. Import Java util.arraylist. It's written right there. So do that import in the top of your program, and away you go. You can use Arraylists. Okay, so the capacity numbers there, we'll talk about that more in a follow-on course. We'll only cover the basics in this course. We'll talk about optimizations, tricks and traps, and so on. We'll talk about all those sorts of things in the follow-on course, even though we won't go into them very, very much deeper, because we really need a third and a fourth Java course to cover things properly. Okay, so there's some of the methods we just saw in the Java help. The rest of them, there's a whole bunch of methods there you can use. Have a look at the help. They're the main ones you'll find useful though. Okay, coming up to the end. Oh, quick example first. So a list of strings called names. Add Abigail, display name. So we're calling the display method down here. That'll just show Abigail. Add Brian, display name. So now it should be Abigail and then Brian. Add Zachary and display name. So now it should be Abigail, Brian, Zachary. And then add Christy at index 2 in the array list. Okay, so it's doing an insert into there and shuffling other ones down. I'll let you work out which ones shuffled down. We did it in the earlier example on the notes over here. And then display names again. And then we remove 1. So we're removing the string at index location 1. So it starts at 0. The second one's number 1. And then display names again. And then set 0 to a net. So replacing whatever's in the first location, replacing that with the string a net, and then displaying again. So I'll let you work through that. And we've virtually did it already. Okay. The last thing we're going to cover this class is enumerated types. So enumerated types are programmer-created data types with a fixed set of values. To create an enumerated type, the user uses the enum keyword, an identifier for the type, in other words, the name that you give it, and a set of curly braces, and then a list of values inside there separated by commas. And it's common to make them uppercase because they really are constants. So for example, month, enum month, open curly brackets, close curly brackets, semicolon, don't forget your semicolons. And then inside the curly brackets, you can give a comma separated list of values. They've got to be unique. So you can't have Jan twice, for example, Jan, Feb, March, and so on up to December. Okay. So then in your code, let's leave that next slide. That's a bit scary for now. So the example I gave in class was you could have a game status for your computer game if you're working on a game. Enum game status. And you could have game over, in progress, game won, game lost, game drawn, whatever else you might have that makes sense. You know. And if you want to set a game status, you can declare a game status field or variable. Game status equals game status.gameover. So you can use any of the values in that list to set a game status, and that's fine. So you could say status equals game in progress. That would be fine as well, because that's the value in the list. Status equals game status in progress. So you've got to use the enum type name, the enum name dot value name. So it's game status dot. Game status dot. You can't do things like just give it a value of 5. That's not going to work. You can't say status equal game status dot finish, because finished isn't in our list. And you can do things like while status is not equal to game status dot game over. So this is your main game loop. While the game's not over, get user input, move the player, move the monsters, check for collisions, do whatever else you need to do. Okay, so that could be the basis for a game loop. Before Java 7, you had to do it the old way, and that was, for example, using compare to or equals. And you can say if status equals game status.game over. If that's false, then you're no longer got to go. If it's equal to game over is true, then your game's over. That was the way you had to do things originally, but with Java 7 onwards, you could just say that sort of thing. And so you could do things like birth month to string, des, or May, and it would return the value May. So it's converting it to a string. So that's a method you can do. There's a toString built in. There's ordinal values. So you could say birth month dot ordinal. And if you're giving it the value May, which is everything starts at 0. So here it's 0, 1, 2, 3, 4. So these are just labels for constants behind the scenes. But they're labels that are nice and descriptive. Okay, so game over is a lot more descriptive than a value of 0. Okay, and in progress is a lot more descriptive than a value of 1, and so on. Okay, so that's why they're so good. But for our birth months enum, if we had a value of May, then that's an ordinal value of 4. Okay, so birth month ordinal. If the birth month has got a value of May, then that's ordinal value of 4, 0, 1, 2, 3, 4. You can use equals if you want to, compare to compare whether it's the start or the end of the, before or after that item in the list, and so on, and so on. So pretty powerful stuff. And you can use value of, so you can go month value of des, and that will return the des enum constant. So you can convert strings to enumerated constants. And month.values returns an array of the values in the enum. Let's look at an example. So month, birth month. We've got a month enum that we looked at earlier up there. And so for month, mon in our month array, so month.values returns an array of those values. Okay, so for month, mon in our month values array, we can print them out to the screen. Enter the first 3 letters of your birth month. Get the entry from the user. So it's a string coming in. User entry is a string. Birth month is a month type. So it's a type enum. Birth month equals month.value of user entry. So we're converting a string to a constant, one of the constants in our month enum. And if that doesn't work, if they type in XYZ, for example, that's not going to work. So our program's just going to crash at this stage because we couldn't convert that value XYZ to anything that's in that array. So it's going to crash our program at this stage. You can get the position as well with the ordinal method. So birth month.ordinal. So if they type in May, it'll give you 0, 1, 2, 3, 4, the value 4. May's the 5th month, so it's index location 4. So position would be 4. And if you add 1 to position, that'll give you the proper month number, which is 5. Then you can do compare tos. You can compare it to June and see whether your birth month is in the start of the year or the end of the year with the result of a compare to. Okay, so pretty powerful stuff with a pretty simple structure. So the big advantage is you can assign nice labels to variables you want to keep track of and not have to worry about keeping track of 0, 1, 2, 3 or a whole bunch of Boolean fields or something nasty. Okay, so much, much better. if you start finding yourself using status of 1 equals this, and the status of 2 equals that, and the status of 3 equals something else, stop. Okay, and change over to an enum. You can also declare an enumerator type in its own file, and the file name matches the type name. So it's got to be, for example, game status with exactly that same case, .java. So you can do that if you want to. Or else you can just put it in amongst your code, for example, up here as part of your method, in amongst your metadata, or you can declare it locally inside here, inside the method if you want to. Okay. So you can put enums anywhere you like, or else you can put them in your own file with in this case, it would be month.java. So move that into its own file called month.java. Put it in the same folder as this current project, and Java will find it, compile it when you do a compile and run. Starting with Java 7, you can use comparison operators with enum constants. That's just what I was talking about here. So you can use the comparison operators with enum constants directly, rather than going .equals or .compare to. You can use enums to control a switch structure. For example, here, we've got a property enum, which has got single family, multiple family, condominium, land, and business. And here we're saying property prop for sale equals property dot multiple family. So we're saying that's the type of property that our property for sale is. Okay. And then we're doing a switch on property for sale, prop for sale. And if it's a single family or a multi-family, we can say the listing fee is 5%, and then a break. Don't forget your breaks. Then if it's a condominium, our listing fee is 6%, and then a break. Don't forget your breaks. So if it's either of those cases, we get 5%. Otherwise, if it's condominium, we get 6%. Or if it's a land or business, then we don't handle this type of property. And of course, there's no need for break on that last one because it's the end of the structure anyway. So there's no need. You can put a break there if you want. Okay, so that's doing a switch on a enum. So the advantages of creating an enum type: only allowed values can be assigned. For it's only the values that you assign inside the curly brackets can be used. Using enums will make values type safe, so you can't assign it to something outside like finish, because finish doesn't exist here. Provides a form of self-documentation because you're providing the names for those entries. If they're not clear, make them clear. It's your name, so you make them clear. Okay, and normally they're all uppercase because they're constants. They're actually constants for integers. That's the constant for integer 0, 1, 2, 3, and so on. Okay, behind the scenes. You can also add methods and other fields to an enum, so you can actually make them so they've got their own class. So you can have constructors, mutators, accessors, toString. You can have extra class, extra static instance fields. Okay, so it's not just, for example, those fields. You can have a whole bunch of other stuff. You can have descriptions for what each of those codes means. You can have, whether they're valid or whether they're enabled or not. You can have a whole lot of stuff going on. Okay, and a whole lot of stuff there you can do with enums. You can have constructors, mutators, accessors, toString, compare to, equals, clone, a whole bunch of other methods as well. And that's something we'll follow up more on in a follow-on course. So we're just scratching the surface here with all of these topics. It's a huge pyramid. All these topics are huge iceberg topics, and we're just looking at the very top of the iceberg, and there's a whole lot of stuff below the surface that we're not looking at yet. So, and we'll look at a little bit more detail in the follow-on course, but really we need 4, 5, 6 Java courses, and even then we're barely scratching the surface. There's so much to know, really. Okay, so lots of good advantages there. Okay, so now, like with everything we've done, and there was no questions there, so everyone was happy with enums. So even at the simplest, even using them in the simplest form, they're still so powerful. Instead of having to worry about game status equals 1 means a game's in progress or game's over, you can just use nice names that you give. Okay, so much better than remembering that 0 means over and 1 means in progress and 2 means whatever. So just on that alone, they're worth using. But when you get down into here with all this extra power that you can do, you can make them look like their own class, then they're just super powerful. And we talk about that more in the follow-on course. So that's it for this course. for this lecture. So it's now over to you to do it. And it's only by writing the code and solving problems that you'll become comfortable with things. So write the code, solve problems, do all the textbook questions, do all the tube questions, grab all the lecture examples, type them into TextPad or copy them into TextPad and pull them apart and put print line statements in there and change them and adapt them and get them so they do extra things. And this sort of stuff will become comfortable for you really quickly. Okay, so there's no questions at the end of the class, so that's where we ended. It was a shame my real recording didn't record. What a pain Zoom is sometimes. But anyway, that's what I should have triple checked after I rebooted. Even though I've got it set to auto record, I should have triple checked. Never mind. I won't fall for that again. Anyway, I hope that was useful. Thanks for watching and see you in the tutes. Get lots of practice writing code. Okay. Thanks for watching.